Hello everyone, welcome back to the Gate Engineering Online Learning classes. In this video of Quick Revision series, we will discuss about Series RLC circuit and a problem. This is the second part of the Series RLC circuit. In the first part, we have seen one problem, and here we will see another problem related to the Series RLC circuit. So before starting to discuss about that problem, just we quickly understand the Series RLC circuit. This circuit is called Series RLC circuit because uh, this circuit consists of the resistor, inductor, and capacitor all connected in the series. Voltage across resistor is VR, voltage across inductor is VL, voltage across capacitor is VC, and supplied voltage is Vs. Current flowing through the supplied voltage is the current IT. And if you find out the voltages across the resistor, inductor, and capacitor, then it can be calculated by VR is equal to IR, VL is equal to IXL, and I is the same current which is flowing in the all the component, and VC is IXC. That can be easily calculated by, and XL is nothing but omega L, and XC is 1 divided by omega C. All these are the magnitude of the inductive reactance and capacitive reactance respectively. If you find out the impedance, that impedance can be calculated by V divided by I. This is the one way if we know the current and we know the voltages, or we can calculate the impedance by using square root of R square plus XL minus XC whole square. Other than that, calculation of power factor, that is called as cos pi, it can be calculated by excuse me, power factor is the cos pi, which can be calculated by R divided by Z. So we have already seen a problem based on this formula in the previous video. So here we'll see a different case of the series RLC circuit example. So in the previous video, we have seen this example in which we had given the resistor, inductor, and capacitor, and we have also given the supplied voltage. In this question, it was asked to find the impedance, circuit current, power factor, and voltage phasor diagram. For the explanation of this video, you can go through the video that is given in the V card of this at the top of the this video. So you can go to that link and you can see the solution of this example. Now coming to the problem here, in this problem we don't have given any circuit, but in the previous case we have given the circuit diagram with the explanation, and here I assume we don't have any circuit, and in these questions we have given the voltages across the resistor and inductor. Instead of here we have given the voltages across the inductor and resistor instead of the value of the resistor and inductor. In the previous case we have given the resistor and inductor capacitor value, but here we don't have given. In this question we need to find the inductance, resistance, and capacitance. Let me see, we understand this problem and we draw the circuit diagram as per the given information. So a circuit consists of a pure resistor, pure inductor, and pure capacitor connected in series. So first of all I will draw a series connections of resistor, inductor, and a capacitor. All are connected in the series. When the circuit is supplied with 100 volt 50 hertz supply. So this circuit is getting the supply from a voltage source of 100 volt with 50 hertz frequency. So this voltage source supply is 100 volt and frequency of this source is 50. The voltage across inductor is given as 240 volts. So here we have given VL is 240 volt and resistor is 90 volt. So VR, voltage across resistor, is 90 volt. If the circuit takes 10 ampere leading current, current is also given. Current is 10 ampere. It's 10 ampere current is given. It's leading current. Calculate a value of inductance, resistance, and capacitance. So what is the meaning of leading current? Leading means like network. In the network, current is leading than the voltage. It means leading current. If voltage is leading, it means voltage angle is more compared to the current. But here current is leading, it means phase angle in the current will be more compared to the voltage. So here now we'll see how to find the inductance, resistance, and capacitance. So it is asking to find the inductance, capacitance, and resistance. Other than that, we need to find the power factor and voltage across the capacitor. So this is the question actually we have given. This is a circuit diagram that we have drawn. This is the RLC series circuit diagram that we have drawn from the given information. So let me start to solve the problem. So in the first part, we need to find the inductance, resistance, and capacitance. So as we have given a current properly, we have given the current which is flowing through the resistor, inductor, and capacitor. The same current is flowing through all the components. So we know current in the resistor is what? V divided by R. Or we can say that current in the resistor is V divided by R. Or we can say that resistor will be V divided by I. Resistance will be voltage divided by current. So this voltage is what? Voltage across the resistance. We want to find the resistance. So voltage across the resistance is VR and current flowing through the resistance is I. So it will be 90 divided by 10, which is equal to 9 ohm. Your current in the ampere, that's why resistance in the ohm. If current will be in the milliampere, resistor will be in the kilo. Now to find out the inductance, we know inductive reactance is nothing but the VL divided by I. Inductive reactance is the VL divided by I, and VL is 240 volt and current is 10 ampere. So from here, XL is 24 ohm. To find out the inductance, we need to find the inductance instead of the inductive reactance. To find out the inductance, we can write L is equal to, or we know XL is equal to 2 pi FL. So from here, L is equal to XL divided by 2 pi F. XL is 224, 2 pi frequency is 50. If we solve this, we are getting the inductance value which is equal to 0.076 Henry. 0.076 Henry. And now to find out the capacitance, we don't know the voltage, we don't know the impedance. If we know the voltage across the capacitance, we can calculate the capacitance also by using the same method, like Xc is equal to Vc divided by I. But here we don't have information about the Vc, so it's better if we find the impedance first, because impedance is nothing but voltage divided by current, and here voltage, supplied voltage is 100, current is 10 ampere, so impedance is 10 ohm. So impedance is 10 ohm. Now impedance is known, resistance is known, inductance is also known. We can find the capacitance with the help of this formula. We know the formula of impedance, that is Z is equal to square root of R square plus XL minus XC whole square. We have calculated Z is 10, XL is 0.076 Henry, R is 9. So we substitute all those information. Z is 10, R is 9, so it will be 9 square plus, it can also be written as XC minus XL. So I can write XC minus XL. So value of XL is 0.076 whole square, because A minus B whole square is same as the B minus A whole square. So here XL minus XC can also be represented by XC minus XL, because we need to find the XC and we want the positive value of that. So if we simplify these equations by taking the square of both sides, we take the square from both sides, we can easily find the XC value, and XC can be calculated from this equation, that is equal to 28.36 ohm. And next part is that for calculation of capacitance, that is 1 divided by 2 pi FC. So 2 pi into frequency is 50 into capacitance is unknown, that we need to find. Xc is 28.36. From here, if we solve it, we can easily calculate the Xc, that is 112.24 microfarad. This is the answer for the capacitance. And we have done the first part for the calculation of inductance, resistance, and capacitance. Now we need to find the power factor of the circuit. And power factor is what? It's nothing but, again, it's cos phi, which is equal to R divided by Z. R is equal to 9 and Z is equal to 10. So power factor is 0.9. So here you can see R is 9 and Z is 10. So power factor is 9.10, which is 0.9. Next part is the voltage across the capacitor. Now it's easy part, because we know the capacitance value, we know the current through the capacitance, so voltage will be IXC. And current I is the 10 and XC is what, that is given here, 28.36. So it is equal to 283.6 volt. So we have seen this example in detail. So in this example, first we calculated the resistance, which is VR divided by I. Then we calculated the Inductance, for the calculation of inductance, first we calculated the inductive reactance, that is XL, which is VL divided by I. VL was given, current is also given. After calculation of XL, we easily calculated the inductance, that is XL divided by 2 pi F. Frequency is 50 in this example here. After that, we calculated the impedance, that is V divided by I, voltage divided by current, and voltage is 100, current is 10. So impedance is also calculated. In the next part, we find out the capacitance with the help of impedance, resistance, and inductance, because all these information are calculated. Only unknown parameter is the Xc. So after calculation of Xc, we calculated the capacitance, which is 2 pi Fc into 2 pi F into Xc. The capacitance is 112.24 microfarad. After the calculation of all these components of the circuit, we find out the power factor, which is cos pi R divided by Z. So R was 9 and impedance is 10, so it is 0.9. After the calculation of that, we find out the voltage across the capacitor, and that can be calculated by IXC. I is 10 and XC is 28.36. So here voltage is 283.6 volt. So this is the problem related to the series RLC circuit. I hope it will be very clear to all. Thank you so much for watching this video.